Picture this. Alex and Josh are twins. At the age of 20, Alex leaves in a spaceship to travel to a planet some light years away and back again. Alex thinks that when he returns, he will be older than Josh, since in Alex's frame of reference, the Earth is receding from him and his spaceship is essentially standing still in space. Josh does not agree. If Alex travels to a planet 8.6 light years away, in a spaceship with a maximum speed of 0.9 c, he reaches the planet in approximately 9.6 years. A round trip takes him just over 19 years. When he gets back, however, he has only aged 8.3 years compared to Josh, who has aged the full 19. So, what the heck? This is called the twin paradox. Alex returns to Earth to find that time is dilated in his frame of reference, but not in the reference frame of Josh, the twin on Earth. We already know that the faster something moves through space, the slower it moves through time. And only observers in an inertial, non-accelerating state, in this case Josh, can observe the time passing at a slower rate on Alex's spaceship. This relationship can be quantified with this formula, called the Lorentz factor, or the dilation factor, and the length of a moving object, as measured by an observer at rest, will contract by the same factor. The dilation factor in this case is roughly 2.3, so time in Alex's spaceship slows down by a factor of 2.3. Alex, in his own frame of reference, is completely unaware of any change in the passage of time aboard his spaceship. All clocks on board and even his biological functions slow down as well. However, Alex's frame of reference is not inertial since he's accelerating when he changes direction in the ship. Because of this, Alex and Josh's respective frame of references are not symmetrical or equivalent, and therefore Alex and Josh cannot draw the same conclusions. As time slows down, the length of his trip shortens as well by the same factor, 2.3. It changes from 8.6 light years to 3.7, making the total distance of the round trip 7.4 light years. With that in mind, and a speed of 0.9 c in the spaceship, Alex only sees the trip take 8.3 years despite Josh and the rest of the Earth aging 19.